So hello everyone, in this session we'll be learning about ADR instruction, which stands for address relative. Before we understand about ADR in depth, very first thing you should know is it's not an actual instruction but a pseudo instruction. You always write it in this particular format, that is ADR, followed by some register. In this particular case I have taken register R0 followed by some label. Okay, and what does this instruction do? The address associated with this label will be stored in the register R0. You always choose ADR instruction if you want to access the address of a particular memory location. You cannot use this instruction to access actual data. Okay, to do that you'll have to again use your LDR instruction. Okay, usually this particular instruction is used if you want pointer to a particular data. Okay, like for example some string, array, etc. Okay, rather than the actual data. Whenever you hear the term pseudo instruction, you should know that as soon as assembler sees this, it immediately converts it into two or more other valid ARM instructions. In this particular case, ADR is either converted to add or subtract instruction, that is arithmetic operation. And how exactly it gets converted? Now in this particular case it gets converted to add R0, comma PC, comma hash offset. Why it is called address relative? The reason is, in this particular case, rather than calculating absolute address, it checks how far ahead or far behind is the required address of this particular label with respect to PC. Okay, PC is your program counter. What it will do is it will perform either PC plus some offset to reach this particular address, or it will be PC minus offset. In that particular case, instead of addition, this instruction will get converted to subtraction. Both these cases are possible depending upon whether the desired address is ahead of current PC or it is behind it. So this is one thing you should know, that ADR gets converted to either addition or subtraction. And the PC here is actually the internal PC, which is current instruction address plus 8. So offset is nothing but address of message, that is nothing but the label, minus your current instruction address plus 8. The 8 is added due to the pipeline concept available in ARM. Okay, so this offset is either added to PC or subtracted from PC to generate the desired relative address, which is then stored in the specified register. There is some condition for the offset. The maximum bits it can be composed of is 12 bits. Now because the immediate value can only be of 12 bit in case of addition and subtraction, this will give you, if you consider the all possible decimal values here, it is 0 to 4095. Okay, so total 4096 values. That's why the range allowed for this is plus or minus 4 KB. So if you want to access a memory location which is too far from your current PC location, then instead of using ADR instruction, you can use LDR instruction, something like this. Okay, now let us execute our actual instructions. There are no errors, so we'll go ahead with the debugging. So if I show here, okay, let me point on this particular instruction, that is ADR R0 comma message. If you see here, it's actually converted to add R0 comma PC comma has 0. Why is this the case? PC here is internal PC, which points at current instruction address plus 8. What will be current instruction address plus 8? It will actually be pointing here only. Why is that the case? If this is your current instruction address, plus 4 means it will point here, plus 8 means it will point here. So what should be the additional offset that should be added? It is actually 0. Okay, so because of this particular reason, we have add r0 comma pc comma has 0. Okay, so let's execute that. The address stored in r0 is actually 8. Okay, so this 8 is nothing but the address of this particular string. Now let's see if that address is proper. At the address 8, I can see these data. Is it correct? See, actually what you should know is, if you consider this particular string, each character here occupies 1 byte of memory, and if you check carefully, the number 48 is the ASCII value of the capital letter H, 65 is the ASCII value of E, and this continues in the same manner. Fine. So the data shown here is actually how hello ARM7 is stored in the memory. So from that, what we understand is this has properly carried out its function, and R0 is correctly pointing at the address of this particular message. Okay, and in our code we are just jumping to loop, we are not doing anything, but you can just add few more lines of code to make it work for UART or for any other purpose.